Did you want us to pick this up?
I did, yeah. Anytime there's a handout up there, y'all need to pick it up.
Yeah.
That's okay. Bathroom. Come back.
You do not have time.
Okay. Can I just take a call fast so I'm not late?
No. You gotta budget that in your lunchtime. If you need to go, go. I don't think you have the punishment until 3 parties in 1 week, so you should be fine. But you need to plan ahead.
Alright. Sounds good.
After 10 minutes, you can use the pass. There's no pass the first 10 minutes or last 10 minutes.
I see that. Okay. Alright.
I'm sorry.
Never mind.
Alright, to start off today, I need y'all to find your book assignment, which should be numbered as number 9 in your binder. Okay, so last time I saw you guys, there was 6 questions, I think, from the book assignment that I put you off on. And it was just that not everybody was there yet, so I didn't want to go over those and then only half the class really be prepared for that. So questions 37 through 42 are what I'm going to look at first. I'm going to go over those with you. And then I'll take whatever other book questions you had trouble finishing, because that was your homework, so you should know what that is. But once we get to that point where I take whatever other questions you have, the handout you guys picked up on your way in is number 10. And again, we don't offer this all year long, but this is another practice quiz. So the front is similar to what you should expect. Your quiz to be difficulty-wise, question types, all that kind of stuff, so you get some feedback. And as always, you should check your answers to that when you get to it, and then try to learn from your mistakes. And then the back of that worksheet will be a second practice quiz. And then finally, I'll have you turn in some of that stuff in the Google Classroom like you did last time. But to get going here, let's look at 37 through 42. Now again, I know I have all of these worked out on my website, so if you happen to take that initiative and you already watched those, you are welcome to move on to the practice quiz. Okay, so for this first one, I'm going to show you two different ways to go about this. I don't want to work all of them two ways, but I'd like for you to know that, like on your quiz, when it's worth a little bit more than just a random homework question, how you could work it both ways to check to see if it's correct. But what I'm going to lean on after this first one, because honestly this is the easiest, at some point, for other things we do, you need to know which two trig functions are even and which four are odd. And if you know what it means to be even and what it means to be odd, this is honestly like a 5-second question. And then this one, usually if you can get part A right, part B is talking about the same angle, so then that's pretty easy. So what it means to be even, what I'm going to refer to on all four of these, the first four at least, is whether I plug in a positive angle or the negative version of that angle. If it's an even function, the values stay the same. Cosine of 30 degrees is the same as cosine of negative 30. Cosine of 60 degrees is the same thing as cosine of negative 60. That's what that means. But odd, like this one, means that plugging in a positive angle versus a negative angle, these are not the same thing unless you multiply one of them by a negative. So for me, because I know this, I know sine is odd, and I know that means that they're only equal if I multiply one by a negative. This 1/2 needs to become negative 1/2, and that's all I have to do. Yeah.
Is the sine theta the same as like sine t? As seen in the question.
Yeah, so theta is the most common way to refer to an angle. We usually use Greek symbols, but t is just a different way to say the angle, so same thing. That doesn't matter. And then these two are the same angle, and cosecant is just the reciprocal of sine, so again, that one's just flipping it over. That's the easy part. Now, let me say one more thing, because I think there's one more connection that will help you guys understand what I'm saying here. Let me refer to unit circle for just a second, and I'm not going to beat you over the head with this all the time, but let's compare an angle to his opposite angle. So 30 degrees to negative 30 degrees. What is the cosine at 30 degrees? Square root of 3 over 2. What's the cosine at negative 30 degrees? Square root of 3 over 2, right? You see how they have the same x value? So they have the same cosine. So whether it's a positive angle like 30 or a negative angle like negative 30, because cosine's an even function, these two are equal to each other. But sine is odd. The sine of 30 degrees is a half, but do you see how this cannot be a half? Because it's going down, right? It's negative a half. So sine, since it's odd, these two are only equal to each other if you multiply one of them by a negative. That's why I multiplied this 1/2 by a negative. So to me, that's easier, because again, I know this, and it makes these questions very, very quick and easy. Either you multiply by a negative or you don't. But for some of these other questions, we're going to need to pull out this technique anyway. So a second way you could try to approach this question is you could say, well, maybe I don't know how big angle T is, but I'm going to do my best to sketch angle T. And if the sine is a half, sine is the y value. So I'm basically trying to give myself a picture over here, a visual of what this is saying. Now, if I want to know what the sine of negative t is, well, if t is about this much going up, then negative t would be the same amount going down. And if I want to know sine, I want to know the y value. And what would the y value be here? because it's going down the same way, the same amount this one was going up, right? So, two different ways you can come out to that answer. Sometimes the pictures are harder to make, so it's nice to have some options, but long term, this one will be more beneficial to you because you'll need this for other stuff later anyway. So, okay, so if we continue this, I'll show you how quick and easy the next three can be. If sine of t is 3/8, then the sine of positive t, you're pretty much just deciding if you multiply it by a negative or not. So do you think this should be 3/8 or negative 3/8? Negative. Sine is odd, so they're only equal if you multiply by a negative. Does not require more thought than that. Although you can try to do the visual, you can try to do the picture. These two are the same angle. Cosecant is just the reciprocal of sine, so you can just flip that over. Part B is not a big deal. Okay, if we try the same thing with 39, I'm going to do the second part of 39 first because it's talking about the same angle, negative t. So secant and cosine are reciprocals, so I can just flip this one over. I didn't need part A for this one. But now, again, it's either going to be negative 1/5 or positive 1/5. You're trying to figure out if you should multiply this by negative or not. So on this one, what do you think? Positive or negative? Okay, this one, these two should be equal because cosine is even, and that's what it means to be even. Whether you plug in a positive t or a negative t, they're automatically equal. You don't need to multiply any of them by negative. Okay, and then the last one of these, normally I would ask you to practice it, but you guys do have a couple of these on your practice quiz, so we can just go over it together. Okay, so cosine's an even function, which means that these two should be what? Well, not necessarily both negative, but these two should both be the same, right? Stays the same. So negative 3/4. Secant and cosine are reciprocals. These two are talking about the same angle, so flip it over and you should be done. So I'm not saying it's the only way knowing your even and odd functions, but it is the most efficient way. Okay, so these four all kind of fit together. Is there any questions y'all want to ask about those before we look at 41 and 42? 41 and 42 we have to do pictures for. Okay, then 41. Tells us sine is 4/5, and we're supposed to be able to figure out what sine of pi minus t would be, and sine of t plus pi. Now, these are different than the first four because we can't just use even and odd on these. This isn't just negative t, it's the angle pi subtract the angle t, or the angle pi added to the angle t. So we really need to try to do a picture for these. So I'm going to try to, again, I don't know how big angle t is, but I'm going to give myself a visual. So I'm going to estimate t looks something like this, and I know his sine is 4/5. Remember, sine's the y values. All right, so the first one, I guess the most common mistake is sometimes you guys try to get like a ratio here, and then you like try to add pi or subtract pi to your answer, but you're mixing up two different things when you do that. These are like the location. Where does your angle stop? This is a ratio, what the value is equal to. You shouldn't have pi stuff over here. Pi is helping you land where you're supposed to land. So on the unit circle, where is pi going to be? Okay. So if this is where pi is, I want to know the angle pi subtract t. So if I'm estimating t looks about this big, that's how much I'm going to take away from pi. And now this angle is roughly pi minus t. And I would like to know the sine value there. So sine is the y value. And what would the y value here be? Alright, it's the same as this one. Same y value, so same sine value. And that's real obvious if you get the picture correct. That's where you got to practice the pictures. Okay, the other half of the question says, I'm going to try to erase some of this out of the way. If you were to take this angle t, which is about this, I've estimated it, and I want to add pi to that angle, well, how much is a rotation if I want to add pi radians? How much should I turn? Okay, so halfway around. If 2 pi is all the way around, 1 pi is halfway around. So here's t add halfway around would be about here. This is roughly t plus pi. And I want to know sine. So I'm interested in what is the y value at that point. So, right, if this one's going up 4/5, I can see, even though my picture is not drawn the scale that well, this one would be down 4/5. It's not going to just randomly be some different number. It's not going to be 5/13 or something like that. You're pretty much just trying to see if I'm keeping it the same or changing it by multiplying it by a negative. You can make the picture. You can see that the y value stayed the same, so these stayed the same, or the y values, one's going up and the other one's going down, so the one must be negative. It's a lot more obvious with the picture, but you do have to practice that. All right, one more. So 42. This one gives us cosine. And then we want to do cosine of the same type of angles. Now, more power to you if you can do this in your head, but even though I've done this for like 12 years or something, I still feel way more comfortable if I try to sketch this picture. So I'm going to try to make an angle T that has a cosine of 4/5. Why did I put 4/5 down as the x value instead of the y value like the last question? Yeah, cosine's x, sine's y. So this is a reasonable estimate for what t should look like. It's not perfect, but it's going to be good enough for this question. All right, part A wants me to figure out what's the x value, what's the cosine, if the angle was at pi minus t. So here's where pi is, and t is about this big. So I want to take off an angle this big away from this angle. So that's going to put it at about right here. This is not quite pi. It's like pi taking away how big I said t was. And if I want cosine, I want the x value. And what do you think the x value is? Right. If this one is 4/5, this one is going left, so negative 4/5. Easy to see once you have your picture set up. And then second half, start at t, whatever your picture looks like, add pi, which is halfway around. Here's t plus pi. And if I want cosine, I want the x value there. And what do you think the x value is? Negative 4/5. However much this one was going right is how much this one's going left. All comes down to the picture. But sometimes both signs could change. 42, both signs changed. But 41, one side changed and one side didn't change. You shouldn't be trying to oversimplify it in your head. Practice making the picture, and if it's even reasonably close to being right, then you'll have a very good idea of what the answer should be. Okay, so those are the ones that I had for you. So what else from the book assignment can I help with? Aaron, you need to get up. Is there any other book questions that y'all had trouble finishing or getting the right answer to?
What about like the last, like true or false questions and the
Okay, which one?
really all of them, I guess just the first one.
Okay, because sine of negative t equals because this is true, so they're telling you this is true, this is what it means to be an odd function. The sine of a negative angle, so if t was something negative, does that mean that the sine would also have to be negative something? Well, the only way to really do this is to try to investigate. So if here's some negative angles, right? Because we start here at the standard position. Is sine negative here? Yes, because it's the y values are negative, right? But if I go far enough, if my negative value becomes far enough, like here, like negative 7 pi over 6, now the sine is positive, so there's a counterexample. Just because your angle's negative doesn't mean that your sine is negative. If you go far enough, eventually the y values are no longer negative, which is what sine is. Okay, 52 says the real number 0 corresponds to the number 0, 1. So where is 0 on our unit circle?
On the x-axis.
Okay, right here is 0. And what's the point here?
0, 1.
Like that?
Wait, no, 1, 0.
1, 0. So what they're saying is false. They're saying if you plot that point correctly. You're going right 1, up 0. And I don't know what the other ones were. Was it 53?
53 and 54.
Okay, 53 wants to know if this is true. So if I try to make a picture here, angle A could look like that. What happens if I take away 2 pi? How much do I have to turn if I want to take away 2 pi?
360.
Okay, so here, this is where A is, but also if I go this direction all the way around, it's also A minus 2 pi. What if I go around the second time? This,
4 pi.
okay. And if I go all the way around the third time,
A minus 6 pi.
all of these angles, you see that they're in the same location, so we call those coterminal. They're far from the same angle. One angle barely opens up, one angle goes all the way around and barely opens up, one angle goes all the way around twice and barely opens up, one angle goes all the way around 3 times and barely opens up. But if they all land in the same place, then they all have the same sine and cosine, and tangent's always sine divided by cosine. So this would be true. They have the same sine and cosine, then they're going to have the same tangent. So basically they wanted you to see that this minus 6 pi still lands in the same spot, so they're coterminal. And that's why we care about what coterminal means. Not equal angles, but equal trig values.
You should look for those last 53, 51, 52, 52.
I'm sorry?
You should look for those last ones.
It says justify your answer, so there needs to be more than a true or false.
Alright.
Yes. Okay, and then 54. So there's no quick way to do this. Both of these are basically unit circle questions. This lands on the unit circle, and this lands on the unit circle. So you either need to add 2 pi to this a couple times to find the angle that's coterminal to it that you memorize, or you can just count to it if you practice it. So where does 1 pi over 2 land on the unit circle? Okay, right here. So if you know this is 1 pi over 2, going the other direction makes this negative pi over 2, right? And then you could turn that much again to get to negative 2 pi over 2, turn that much again for negative 3 pi over 2, negative 4, 5, 6, 7. So you've got to be able to find negative 7 pi over 2 somehow. And then from the unit circle, we memorize the point, and cosine is the x value. So the cosine of negative 7 pi over 2 is 0. Over here, you got to do the same thing. I guess you could add these together, get a common denominator, and see that that's 3 pi over 2. Or you could just start off at pi and then add pi over 2. What is the point here on the unit circle?
0 makes 1.
Okay, so what is the cosine at that spot?
3 pi.
3 pi over 2 is the angle, not the cosine of the angle. Cosine is just the x value. So this was equal to 0 and this was equal to 0, so I would say it's true. And what they're trying to get you to get out of this one is negative 7 pi over 2 landed up here on the top of the y-axis. 3 pi over 2 landed down here on the bottom of the y-axis. Totally different angles, totally different locations, but they could still be equal because the cosine of each of these is 0. Everywhere, as you guys go around the unit circle, you need to notice that cosine is 0 in 2 places, cosine is 1 in, oh, not 1, cosine square root of 3 over 2 in 2 places, square root of 2 over 2 in 2 places, 1/2 in 2 places, negative square root of 2 over 2, 2 places. Basically all the values repeat multiple times except for 1 and negative 1. So no quick way to do that. You just actually have to use the unit circle to find this value and use the unit circle to find that value. Okay, was there anything more to those that you want to ask? That's enough? Okay. Somebody else have any other book questions that I can help out with? Okay, that's fine. Just wanted to make sure I gave you a chance. So, I mentioned this earlier just as a quick recap to start class, but the handout y'all picked up needs to be numbered as number 10. So again, this year I am trying to number them before I run off the copies, but I don't always remember that. You guys need to number it because when it comes time to turn stuff in, you need to know what number 10 is. So what I suggest you do is do the front as a practice quiz. Don't use your notes. Don't ask for hints. Just see how many of them you can actually get right. I've got the solutions on my website for you to check. Look at the ones you missed after you check it. Try to learn from your mistakes. And then do the back as a second practice quiz. And then if you're still missing some questions, you need to, I don't know, go back to your notes, ask me for help, but you should at least know what gaps you need to fill in. So, and then finally, I am asking for 3 things in Google Classroom, so I know you guys get those emails. But once you finish up number 10, you should go ahead and turn those 3 things in. One is the 4.2 notes, which I don't always give points for, but I'm asking you to turn it in. The book assignment, which should be finished now because I just finished all your questions, and then this practice quiz. So you need those in Gradebook or in Google Classroom for me to get in the Gradebook before class Thursday. So it makes sense to just do it now so you don't forget about it, or when you finish the worksheet. So to give you time to try that and to maybe give you one hint later, I'm going to let you go ahead and start there. And about 10-15 minutes from now, I'll come around and try to help out. But again, you need to try them without any hints first. You need to see what you actually know, what you actually need to do. Sign out and take the pass.
So basically, cosine is just y values.
Cosine is the x value
X, okay.
on the unit circle.
On the unit circle.
If the radius is not 1, then it's not. But
Okay.
if it's unit circle, which is what we're talking about right now, cosine's x, sine's y.
Okay, and then tangent is just the same thing.
Tangent is sine divided by cosine.
Okay, thank you.
Alright, as I come around, if you need a hint on something, just call me over. Remember, cosine is the x values. So if you're trying to sketch a picture, if cosine is negative, you need to draw it to the left. So it would be probably 2 or 3 maybe. You don't know if it's 2 or 3. But either way, if you swing it halfway around the circle, now it's going right around the circle. Okay, that's why I mentioned it.
Tangent would be, or tangent would be x over 4. Or is
Sine
it-
over cosine. So
Okay.
y over x.
Okay. And then, the 3 things, or 0, 1/2, square root of 2 over 2, and then square root of 3 over 2?
And 1.
Okay.
Well, cosine is like the x value when you're in a circle, and since this is negative, you just need to draw your angle somewhere to the left, anywhere over here cosine. So if you try to sketch an angle T that's in quadrant 2 or 3, that's what T would look like. once you finish the front side and you check your answers, if you don't know why you missed something or how you were supposed to come out with that answer, that's where I can help. When you get there, please speak up.
You're gonna have to wait for the pass to come back. He should be back in a moment though. Yep.
Well, the quick answer is cosine's even, so whether it's t or negative t, the answer stays the same. It's all even functions do that. And then if you can get this one, these are talking about the same angle, secant is the reciprocal of cosine, so we'll just look it over. That's the quickest way.
Restroom pass. You need to still sign it. Why don't you ask the answer to questions?
You have to like choose to not get myself in that.
That part is wrong. That part is wrong.
Yeah.
I don't know.
We did that one on the board earlier. It'll be on the class recording later, after class.
I think that's when you went to the bathroom. Okay. I'm leaving the agenda up, so if you guys know what reminder to like turn in your Google Classroom stuff. So you know what else you can work on when you finish your practice quizzes.
how to go from here to here. Yep.
So, the part you have to have memorized is that they're reciprocals. So reciprocals just mean that you get to just flip it over, right? But just like your book work, pretty much everything we do in here, square roots in your denominator are considered unsimplified. So this step of you multiply the top and the bottom of your fraction by that same square root. Now when I multiply my numerators, I get this. When I multiply my denominators, I get square root of 4, but that reduces to 2. And then after you cancel and reduce your fraction, you're left with what you need. So anytime you have a square root in your denominator, you need to multiply the top and the bottom by that square root. And it will change its appearance to where you don't have a square root in your denominator. Just leave it hanging there for the next person.
It clicked.
Hmm?
It clicked. Figuring it out.
Oh, okay. I don't know what the question was, so.
Oh, you know, Jack signed up for your voucher tomorrow. You gotta beat him up blockers.
Well, I think I have someone making a quiz tomorrow, so. Oh, wait, it's negative though.
Yeah, so you're right.
Well, cosine's the x values. So for x to be negative, it's gotta be somewhere in quadrant 2 or 3.
So
It's gotta be going left. So I'd say just draw an angle that looks like it's in quadrant 2.
well, wouldn't it be? I thought because it was negative, you go just like you would.
It's not a negative angle, it's a negative ratio.
Okay.
Difference. Big difference.
So then how do you know if it's not going up?
Well, I know cosine the x values, and it's negative. And for x to be negative, I know it has to be in quadrant 2 or 3. So I would just sketch it in one of them. I could probably just do 2.
So how do you know what's this angle versus
You don't.
you know,
Just put it down as a picture. It's going to be close enough.
just add pi to this.
Okay. And then if you add pi, if you were going left 8/17 and you add pi, you must be going right 8/17 now.
Okay, so it's not this be positive. And then goes to and you determine what the x value is, and you don't know which part of it, which part of it.
Well, x is always going to be negative, or it's always positive.
Okay.
When you swing it over, it's always going to be positive.
Would you just say positive or?
When you say positive 8/17,
Okay.
however much it was going left is not how much it's going right.
Okay, so just.
I still think you need to try to sketch that first angle in quadrant 2 or 3.
See that if you swing it around,
It looks like the same x distance, but if the starting one went to the left because it was negative, your answer is positive for this one.
So for this one, you guys get, this is 4. Does the answer true or false?
true.
What's a little review?
Right. So you have this, flip this. So I'll start with one of these, and then map down, so. We're going to have positive. So everyone will have 5, 2, 3, 4, 5, 6, 7.
Right. What's the point there on the circle?
Right here.
That's the spot you want to
So then the.
Okay, so that means the cosine of that angle is what? 0, and now do the same thing for the right side. And you should get 0 there too. Not the same angle, not the same spot, but they both have a cosine of 0. So it is. And that's why it's like that. My advice is to make pictures, so if you haven't done that yet, you gotta try that. Okay? This is number 2 in your binder. Compared to word 3, use that calculator. You got something to do?
Sir.
Look interesting. Finish the back one. You got them turned into Google Classroom. You need to turn in the worksheet 2. That's one of the 3 things you need to turn in. So you could be rounding up your notes, and you could be starting on your worksheet, and turn in the new one. Turn them all in at once. Get that one real quick now. The value's not gonna random. That's all. You're all done. Yeah, right here behind you.
Do you have like extra copies of the practice?
I do. So, on those chairs over there by that table, one of them is for pre-cal. You just have to know the binder number. It's organized that way. And that one's number 10.
Thank you.
But I do have some extras if you want to know. So, are these grades in? Alright, now that everyone's had time to try the front part of that worksheet, I did want to I want to go over one of the questions because I saw it was the most problematic, just trying to look over your shoulders and see. But also I want to give you guys one tip, not because I really don't think I should need to say this if you're approaching your assignments correctly. However, we do allow a calculator on this quiz that we'll be taking next time. But just as an example, if you, on question 2, part A, if you just throw this into your calculator, sine of 11 pi over 6, this may not be the best example, but still makes the point. If you just type that in and you get some decimal and you put decimals all over on your quiz, those are not going to be worth any points. None of these questions said go to your calculator, round to the nearest thousandths in your calculator. You shouldn't have been using your calculator. The reason why I said I don't feel like I should have to say that is because part of your work here is checking your answers. And so if you did that on your practice quiz and then you check your work and the solutions don't have any decimals, then that should be your sign that something's off and you need to ask about it. So I feel like it's almost against you to let you use calculators. But there is one thing that you could do if you're creative. So I'm not going to emphasize this because I don't want you to lean on it too much because you don't always have a calculator. But let's say this was one part of your quiz question, and let's say you were about to turn it in and you thought the answer was, I don't know, square root of 3 over 2. That's a common answer. Well, even though I don't want decimals as an answer, if I ask the calculator what's the answer and it shows me as a decimal, and I tell the calculator what I think the answer is as a decimal, how should you know that this is wrong? These need to be the same, right? So even though I'm not interested in you telling me what the decimal is, here's the calculator's answer, here's my answer. These two are obviously different. So if you're being smart like that, you could say, okay, wait, it's not square root of 3 over 2. Let me do some more work. Maybe now I think it's square root of 2 over 2. You see how these are still not the same thing? So then at least you would know, hey, that's still not right. I got to try something different. And then maybe you correct your unit circle. And then finally you try negative 1/2. That's the same as what your calculator says, so then you would know you're on the right track. So if you're creative with your calculator, you can help check some of your work. So that is an option for us on this quiz. But no decimal answers. You should not be doing that on the practice quiz, so you should not be doing that on the real quiz. But the one that seemed to give y'all the most trouble, so it doesn't hurt to see one more example, was number 6. And you just have to make a picture. On a question like this is not a unit circle ratio, so this is one of the, there's only a couple questions on here that don't have to do with the unit circle. Most of this stuff is unit circle. Everything except for 4, 5, and 6. But this value is not going to radically change. It's not going to all of a sudden become 3/5 or 1/2 or something. It's either going to be 8/17 or negative 8/17. But to work this, you really need to try to sketch this picture. So what do we know about cosine values? Cosine is always the what on the unit circle? X. And when is X negative? What quadrants is X negative? Okay, so when you sketch angle T, you either need to make angle T look like it's in quadrant 2 or quadrant 3. It doesn't matter. How is this angle different? What's the difference between T and T plus pi? What's this plus pi going to do? Okay, so halfway around. So the way I drew it, it's going to put it in quadrant 4. Now this is t plus pi. So this one had a cosine of negative 8/17, because that's how much left it was going. But for this one, it wants the cosine of this angle. So if this one was going left 8/17, it's now going right 8/17. And that's how you know your answer was positive and not negative. But you got to try to sketch that angle. Cosine is x. X is negative in quadrant 2 or 3, so you can draw angle t to look any way you want to, but it needs to be in quadrant 2 or 3. Go halfway around the circle, and now instead of going left this much, you're going right this much. Should still land on the same answer no matter which way you approach it. Alright, so I wanted to talk about that one just because I saw that was by far the one given the most issues, and I wanted to give you heads up about decimal answers and put that in your brain about checking with the calculator, that if you're smart you can potentially check some of your work on your quiz before you turn it in. Okay, so I'm going to keep coming around, but you guys are down to about 20 minutes. So notes, book work, and practice quizzes need to be turned into Google Classroom, preferably now. But it is due at the start of class on Thursday. So if you don't do it now, and then you forget about it, and then you don't have them with you, you'll end up getting late credit. It's better to just turn them in now. So. If there's anything else I can help with, then please ask. The way you're writing it here, looks like you're doing a reciprocal ratio, and what you actually want is a reciprocal trig function. So instead of doing it this way, you need to do 1 over cosine. So not the inside part, the whole thing.